Next, let's take some time to look at some problems that involve trig graphs. So just as a brief summary of what you already know, there are two main equations that we're going to use to analyze trig graphs. The first one is the cosine version of the equation, and the second one is the sine version of the equation. Now when we look at trig graphs, we have these three parameters. A, this is called omega, and this is called phi. And by knowing, if we're given an equation where we can determine A, omega, and phi, then we can determine the amplitude of our trig graph or trig wave. We can determine the period by using this equation. The period, or how often the wave, or how long the wave goes before it repeats, is 2 pi over omega. And then the phase shift, where the whole graph gets moved side to side, is phi over omega. So what I'm going to do is to do a few problems where we're going to be given an equation, and then we're going to be asked to determine the amplitude, period, and phase shift. So, for example, let's just dive in. I think this won't be horribly complicated. So if I'm given this equation, y equals 3 times the cosine of 6x. So x here is your angle, and y is the magnitude of the function. So what you always have to do is, whichever one of these equations you're using, so in this case it's a cosine, I'll do it this time just to make it obvious. You basically, if you want to think about it, you sort of line up what I call the standard equation with the equation you're given, and then you just want to determine what each of these parameters are equal to. So obviously, A is going to be 3. Omega is going to be 6. Now here, because there's nothing subtracted, in this case phi is going to be 0. So now, once we know these parameters, we can determine the information they're asking us for. And this is what they're asking for in the problem. They're asking for the amplitude. So the first question is, what's the amplitude? Well, the amplitude is just A, which in this case would be 3. The next question they ask is the period. We like to label the period T, and according to this up here, little formula for the period is 2 pi over omega. For our equation, we determine omega to be 6. So you put in 6 for omega. So your period is pi over 3. So there's amplitude. There's the period. Now in this case, it's pretty obvious there is no phase shift because phi is 0. On some problems, they may not even ask you this because it's pretty obvious there's no phase shift, but in case they do, you would just say 0. All right, how about another one? Hopefully you don't find these too difficult. So how about this one? y equals -7 sine of 8x. So once again, I'm comparing the equation I'm given with the standard equation in case of sine. So hopefully you can see that A, now you might think A is -7, but A, well, we could call A -7, but the amplitude is always going to be a positive number. So yeah, you can call A -7 or 7, doesn't really matter. Bottom line is the amplitude is going to be 7 here. That's pretty obvious. And then here's our omega, and then we can use that to find the period. So maybe I'll just, to make it simple, do this kind of thing. So therefore, we know the amplitude, which is A, is going to be 7. Now the period, which is T, is 2 pi over omega. Well, omega is 8. So it looks like the period is pi over 4, and once again, there's not going to be any phase shift. A couple more. Once again, these are all, hopefully you find these pretty straightforward. 1/2 cosine of pi x. Remember, pi is a special number, but it is a number. Right, it's not a variable, it's actually a number. So this is going to be my A, and this is my omega. Once again, right, A is what's in front of the cosine, omega is inside the cosine, and it's what's multiplied the coefficient of x. So therefore, I can actually just maybe just go over here and say, the amplitude is going to be 1/2. The period, 2 pi over omega, 2 pi over pi. In this case, the period is 2. And one more, just to show you what they like to do sometimes. They just like to make the math messy. So what if we have y equals 4/5, -4/5 sine of all right, so we got a bunch of fractions, so the math might be a little messy. This is A, this is omega, amplitude, once again, although it's a -4/5 here, amplitude is always positive, so it's just 4/5. The period, 2 pi over omega. Omega is 9/7. So this is now a complex fraction. If you can't remember the shortcuts, what you can do is if you turn a complex fraction into one fraction over one fraction, then the rule is you take the top fraction and you multiply by the reciprocal of the bottom fraction. So it looks like the period should be 14 pi over 9. Let's look at some problems where we have a phase shift. We haven't had any of those yet. So these were just mainly amplitude and period. So now a phase shift would be something like this. Y equals 6 times the sine of three x plus pi over 2. So let me write here, just since this is our first phase shift problem, general equation a times the sine omega x minus phi. So let's figure out what a, omega, and phi are. A is 6. Omega is 3. This can be tricky now. Here's what I typically do. Because this standard equation, you're subtracting phi, here's what always works for me. Because the problem is, when we try and define phi, sometimes people will mess up whether it should be plus or minus. So here's the little rule of thumb I learned to do years ago, and it just works every time. I don't have to think about it. When I look at this, I take the actual value plus whatever's in front of it. So I think of this as a positive pi over 2. And then if I want to determine what phi actually is, I take the opposite sign of this. So if this is positive pi over 2, I know that phi is going to be negative pi over 2. Just as an aside, that whole idea, what if I had cosine of x minus pi over 4? So for the phi, I know phi is basically this here, but should it be plus or minus? I say to myself, I've got a negative pi over 4 here. When I actually define phi, then it has to be the opposite. So for this equation, phi would actually be pi over 4. So let me do one more. Well, if you have sine of 4x plus 2 pi over 3, and I want to know what phi is. So I'm starting out, I have a positive 2 pi over 3. When I define my phi, then the sign always has to change. So that's just a rule of thumb that just works every time, and it's a good way to keep up from making a mistake on the positive and negative signs. So for this one, since I got a positive pi over 2 here, my phi is actually negative pi over 2. Now once I know these, then I can determine amplitude, which I'll do first. Amplitude is always A. Period t, which we've done before, is 2 pi over omega. 2 pi, since omega is 3, it's 2 pi over 3 for the period. And then the phase shift, oops, that's phi. Let me write it out. A phase shift, once again, way back at the start, the equation for the phase shift is phi over omega. So phi is negative pi over 2, and omega is 3. So once again, here's a complex fraction. If you don't know the shortcut, you can always make it one fraction over one fraction, then you write the top fraction multiplied by the reciprocal of the bottom fraction. And for the phase shift, you get negative pi over 6. All right, how about another one? How about y equals 2 cosine 6x plus pi over 2. So once again, first step is always to define your parameters. A is going to be 2. Although once again, the phi here, when I use it to calculate things, it's actually going to be negative pi over 2. So the amplitude is always the easy one. It's always A. So what's 2? Period is always a pretty straightforward calculation, 2 pi over omega. 2 pi over 6, which is pi over 3. And then the phase shift, that's phi over omega. So negative pi over 2 over omega, which is 6. I'll just use the shortcut here. This one ended up being negative pi over 12. All right, not too bad. Now the last kind of problem I want to solve now is where they give you the parameter, not the parameters, but they give you the characteristics of the graph. In other words, they give you an amplitude. They say it's 9. They say the period is 8 pi. And they say the phase shift is 1/3. And what they want you to do is they want you to come up with the equation of this graph. Now they have to tell you whether they want it to be a sine wave or a cosine wave, because you can do either one. In this case, they want the sine wave. So here's our standard equation. So really what we do is now we need to determine A and omega and phi. If we can figure out what those equal, we plug them in here and we have the equation of the trig graph. So they give us this information about the graph. Well, A is going to be easy because you know what A is? A is always the amplitude. So I know that right away. So now I can plug in 9 in for A. How do I find omega? Well, I know the period is 2 pi over omega. So they give me the period. So I can say 8 pi equals 2 pi over omega. Now if I solve this for omega, multiply both sides by omega, divide both sides by 8 pi, I get this, which reduces to 1/4. So now I know omega is 1/4. So I've got two of them. Now I need to figure out what phi is. But we know the equation for phi is going to be, we know the phase shift equals phi over omega. But I know the phase shift. They give me the phase shift. I have just calculated omega in the previous step to be 1/4. So now here I can figure out phi. If I multiply both sides by 1/4, you get phi equals 1/12. So now there's A, there's omega, there's phi. I plug all those into here. Maybe I'll just do it up here. So A is 9 sine, omega's 1/4 x minus 1/12. Let's do one more of those. How about for this one, they say the amplitude is 5. They say the period that's not interesting. I'm going to change it. I'm going to say the period is like 4 pi. They said 8 pi again, and we just did an 8 pi. And then the phase shift is -1/6. And here we're going to find the cosine. So let's say we need to find A, omega, and phi. A is easy, right? A is just 5. The period equals 2 pi over omega. Since the period is 4 pi, 2 pi over omega. Omega would be 2 pi over 4 pi. I believe omega should be 1/2. And the phase shift, which is actually -1/6, but we know that equals phi over omega. So -1/6, we just determined omega to be 1/2. So by the time you do this, you get, phi is -1/12. So now we have everything we need. A is 5, cosine. Omega is 1/2. Now I'm going to be subtracting a -1/12. Which should just be plus 1/12. All right, hopefully not too bad.